good afternoon or morning or evening or whatever, it depends each one to everybody, and thanks for attending this second session of Emerging Minds. This session in particular is more geared towards the ideas of the usage and the applications of artificial intelligence, machine learning, to architectural design, a more generative approach. We have invited two guest speakers, which are really deep into this field, that in a way are part of a wider discussion on how a technology that initially was developed more for reading and understanding patterns has been sort of like lately applied towards generation of information, generation of images, generation of designs, generation of realities somehow. What I think is quite interesting was this idea that somehow, depending on what you use to train, to create these algorithms, actually you are fabricating a new form of agent, a new form of a companion in the design. Somehow there's another intelligence there sitting side by side with the designer. And that's something which we discussed with Matias and with Enriqueta. That was quite interesting to reflect upon. That's why we called Emerging Agencies this session, and that's the sort of like overarching framework. We have Enriqueta Llabrés speaking, and then Matias del Campo. Enriqueta Llabrés is an architect. She's a TEDx fellow. She lectures at the Bartlett School of Architecture, and she is the Mittelsten Scheidt guest professor at the University of Wuppertal. Together with Zachary Fluker, she leads the research cluster at C18, Fab and Media Urbanism at the Bartlett, and she is the co-founder of and director of Relational Urbanism Lab and Llabrés Taboni Architect. Then we will be followed by a talk by Matias del Campo, who is an associate professor of architecture at the Taubman College, University of Michigan. He co-founded Span Architects, and was awarded the Young Talent Award for Experimental Tendencies in Architecture at the Rudolf Schindler Scholarship from the BMUKK. So without further ado, we'll go to the first session by Enriqueta, then followed by the one by Matias, and with later on a series of questions or session of questions and answers by the audience. So thanks a lot, and the ground is yours, Enriqueta.
Good afternoon, everybody, and thank you for inviting me to the lecture. Can you see my, well, I guess you can see my screen. So what I'm going to talk about today sits in the context of the work that we have been developing at the Bartlett School of Architecture in our C18, but also in Relational Urbanism Lab and Llabrés Taboni Architect. So this environment goes back and forth and sits in the context of urbanizing technologies. In that sense, we believe that design must include the capabilities for interaction and communication between living and non-living entities. In that sense, design is more an information problem than purely formal representative practice, and the construction of the value of the space in a specific time is relational, open-ended, and inclusive. We believe that computational intelligence enables a wider democratic process in the city by decoding the voiceless, that is, all living and non-living intelligence inhabiting the planet. Our design methods are based on the study of knowledge creation processes, questioning what is the nature of creativity and how this is translated into meanings and an aesthetic interpretation of how we see the world. So in that sense, we sent our conceptual framework in trying to break down what is the nature of knowledge creation. And in our design practice and the development of the studio, we always try to see the interrelationships between this form of a knowledge source. So on the one hand, we have tacit knowledge, which is the knowledge that is embodied in the individuals, is related to the experience, and is acquired by senses and face-to-face interaction. It's founded on the idea that we know more than we can tell, and actually it's not only owned by humans, but all the living creatures who have sense of the world and can learn through experience. We also understand knowledge source as codified knowledge and the knowledge that is related to the use of language, and how can we record and capture knowledge and then transmit it without having this face-to-face interaction. In the latest development of artificial intelligence and artificial forms of knowledge creation, we can identify the symbolic and sub-symbolic AI, where symbolic AI sits in the grounds of mathematical reasoning. Sub-symbolic AI is more difficult for humans to grasp because it follows the very structure of the human brain. So despite this is our conceptual framework, what I'm going to talk today, it sits more in the latest category, and what is our exploration about the sub-symbolic AI. Particularly the questions that were raised like 1 year ago in this fantastic lecture series organized by the Barbican, in which they were questioning questions such as, could an algorithm ever write music rival to Bach? So what happens when an algorithm computes aspects that historically being owned by human intelligence, such as music and art? And what kind of design questions we can propose, which design challenges we can embrace thanks to this kind of algorithms? So the first project that we try to explore the use of sub-symbolic AI in design with agriculture, a new pattern for agrarian urbanism. In this project, we claim that agriculture needs to be back to the city due to the fact that we will not have enough land to feed 7 billion humans in the planet. But the problem of stacking agricultural production and introducing agriculture into the architecture is that the city loses the flexibility that the land provides in order to reprogram itself. So how can we reprogram architecture in order to keep for the city, in order to have this flexibility and its capacity to perform as an evolutionary complex system? So of course we could with symbolic AI we could embrace challenges related to the environment and to environmental optimization, but when it came to reprogramming the city, we had to go to a different type of approach. So in here, we are seeing more the design process that took place in order to optimize the location of the urban farming. So the question is, how can you reprogram the architectural block? So in that sense, convolutional neural networks have the ability to process images, particularly in the generative adversarial network. In this case, the students produce a database of greenhouses, but they interpret the database by interpreting the program of these greenhouses into 3 categories of program. The three categories of program had to do with how people could coexist with agricultural production and plants. So they decoded three types of program that were spaces for plants, spaces for people, and spaces for both. Of course, the designer still needs to not only produce the database and have the initiative of what kind of database has to be given in the design process, but it has to train the algorithm. It has to define what is the margin of error that the designer will allow to the algorithm. So here we were questioning whether the machine was creative, meaning that it's not only capable to recognize patterns or repeat, but create new patterns. And what we started to perceive is that actually the granularity and the resolutions of the patterns that the machine was creating was alien to humans. So here we question whether the machines are actually creative. This is how the database then was applied into the architectural model, and how the model was continuously suggesting new forms of association between plant and people. According to Margaret Bowden, creativity needs a framework. In the case of music, the framework is the notes, the rhythms, the instruments. You need a framework in which you situate yourself in order to be creative. In this case, the framework of the machine creativity is given by the designer. The designer is the one that is constraining the space, the creative space of the machine, and the designer enters in a linguistic relation with the machine. So aspects related to granularity and resolution, they are not treated in a parametric way, but are more treated in a descriptive way. In these three images, we can see the structure of the architecture and how the AI starts to suggest a new forms of organization between plants and people. This is an image, the image on the right is an image that was produced by the students. I wasn't so happy about it, the way they rationalize it, but what did strike me in the design process is that actually the designer felt the need to rationalize what the machine was giving. So if you look at previous use of computational technologies, they always help the designer to rationalize the design, where in this case, it looks like the roles are reversed. It is the designer who wants to rationalize back the machine. So I found this as pedagogically very interesting. So this is the way it was applied in the design. The other aspect that I want to talk about in relation to the use of these technologies is the importance of analog errors and corrupting data, and how it is important in a period in we are over-celebrating machine learning, and that we challenge the dominance of data and how it imposes discourses. So currently, the meaning of democracy is challenged by algorithms. The prevalence of the politics of misinformation and data becoming a commodity of digital capitalism. So in this sense, I want to highlight the work of glitch artists, such as Nam June Paik, in which they started to challenge how much we can believe from the data that we are receiving as let's say, as an unquestionable truth, or how media transform reality and the material reality. It corrupts it, and it brings an ideal version of what beauty is. No, so I think in that sense, data is now sold as the basis of neutrality and accuracy, and is presented as the perfect signal for the perfect decision. So we must also confront the hierarchies embedded in the digital culture. So that's why I think it is important to add the idea of data corruption in the design process. And this is what we did in the latest project in Glitch Art, Rewiring Complexities in Architecture, in which we tried to bend the data of history of architecture in order to challenge historical discourses that have been dominant in the architectural practice. So, and okay, so this is another a project from RC18 in which we situate our project in the idea of waste, and how waste production and the municipal waste in cities is increasing exponentially, and how there has been an ongoing alienation that started even in the late 19th century with the Industrial Revolution, between the questions that the architecture practice have put on the table and the material processes that sustain our lifestyle. So mainly we have been preoccupied by how industrialization has challenged the artistic nature of architecture. And then, of course, this has been brought to its, let's say, to speak into modernism. And then, of course, there has been a whole range of discourses that have reacted to that. But in the meantime, there has been an ongoing decentralization of the production systems and decentralization of waste that the architecture has completely ignored. And I think in this project we try to reformulate waste not so much as an economic problem as a cultural problem, and we propose how can we data bend the history of the architecture of culture and to try to corrupt it with the architecture of recycling. So I'm going to go a little bit far. So this is so we again use the same technique. We use the generative adversarial network, but in this case we basically data bind the knowledge source, and we try to corrupt the data in order to look for radical new ways of understanding what the culture means and what waste means, and why questioning why waste is so far away from culture in our contemporary society. So we used the GAN in three different layers. So on in the first part, we used the GAN as a figure ground. So actually, we were introducing the architecture of recycling and the architecture of brutalism, and how they situate in the ground, and what is the urban footprint, how they are related to the outside boundary. And we try to merge these two qualities in order to get a pattern of the city that somehow brings the logic of a cultural center, but at the same time bring the logic of the recycling and wasteland center. And we do iteratively, using the figure ground, the agricultural, the architectural plan, and then how the different layers of facade and the different materials and architectural patterns that you will have in the facade. So in the same way, we process the data and the program of the architecture of both types, the recycling and the brutalism, and we bend it in order to use it as a generative process. So in the materialization, we do the similar process. And here, for me, these are the most inspiring results that the project has, in which you can start to identify merging identity between what it was the brutalism and certain aspects that has to do with an architecture of recycling that has been neglected as architecture in the architectural discourse, but is more neglected to the engineering and the support of what is considered the real architecture. So, yeah. So then we explore how this can be brought back as a generative process and can start to inform new designs and new morphologies that will just create new spaces in the city. Somehow, this image suggests an environment that is not data and is not material. It sits in between. And I think it is very important to understand and to be critical about how much of the world that you know is outside actually being processed by data, and how much is something that you really experience. Even like the way you experience myself is being processed by data. This is not my background. So in that sense, the visualization of the architecture also reflects that, that aspect. So I want to go to the next slide. And maybe the idea of what aspects may be important for the current challenges that we have today in relation to climate change and nature of emergency, which questions have been left aside. One of the comments that I normally hear in academic debates is that currently architecture it's crap. It's really the quality of architecture is not good. And my point is that maybe it's not rubbish enough, and that we need to involve waste and rubbish more with architecture. This is a project that we propose for the Tel Aviv Faculty of Architecture. This is in the practice, and we call it detritus architecture. And basically what we challenge is the idea of the architecture as the the center of the debate of what cities should embrace and what architecture should embrace. And maybe what we should embrace is the fact that currently in the sea there are 5.13 tons of plastic waste, which is 13 times the amount of stars that we have in the Milky Way. So maybe it is time for architecture to look for radical meanings and to question what are the debates that we are engaging in. So in that sense, the brief of the Faculty of Architecture was proposed as a sort of a mixed use where different forms of consumption from restaurant, cinema, shopping, and architecture was put together. And our proposal was maybe you need to stop introducing just consumption in the city, but you need to start to talk about our waste and where the resources that we use are coming from. So this was our proposal for the Faculty of Architecture of Tel Aviv, in which the whole faculty becomes a wasteland, a recycling center, and maybe it can build itself by having an innovative approach to the way we reuse materials. So in that sense, a very challenging view of what the public space should be, and maybe part of our public space should remind us how irresponsible we are with the way we consume and waste our consumption. So yeah, that's basically my talk.
Good, thanks for that. We now go to the second intervention scheduled by Matias del Campo.
Hello, everyone. Can you see my lecture?
Yeah.
Okay, excellent. So first of all, thank you very much for the invitation to join you today. It's a great honor to be able to do a lecture again at the Architectural Association. Very happy about that. Thank you very much. So my name is Matias del Campo. I'm a co-founder of the architecture practice SPAN, together with Sandra Manninger, that we found in Vienna, in Austria. And currently we're also running locations in Shanghai and Detroit. So the lecture today is called Matter Ex Machina, an attempt of an ontological interrogation of architecture and artificial intelligence, and it will maintain and contain a variation of different ideas, possibilities, examples, obsessions, variations, and ugly things that we have been doing with this idea and around this idea. So, but let's first go into a case study of contemporary culture in a post-human universe. And what I mean by that is, just to get it out of the way right away, when I talk about post-human, I'm not talking about the life after humans, but I'm talking about a world where human dominance is not as clear anymore as it used to be, in the sense that, especially in the creative act, we're not anymore on top of the pyramid and controlling everything in a top-down fashion, but basically we're starting to share agency with other agents. And as already mentioned in the introduction, those agents can be also artificial. Now, let me give you some examples to maybe understand the cultural context of where we're currently operating with this idea. So what you see here is the work of German artist Mario Klingemann. He's an avid user of generative adversarial networks. And what I'm interested in that, because that's not a novelty anymore to use GANs, but rather the ways how he's using that. He collects paintings from throughout history, from the last 400 years, especially from portraits, and uses those as a database for his work. Now, what that produces through a process of computation is a world that is rather discussing aspects of estrangement, defamiliarization, aspects of things that were discussed, for example, in Graham Harman's book, Weird Realism, Lovecraft and Philosophy, where ideas of ruination, estrangement, and defamiliarization have a really interesting description. Now, what this means for architecture is the ability to do similar thought experiments, meaning we as a discipline in architecture have a 2,000 plus year archive of ideas, plans, sections, ways how to accumulate matter to create space or to enclose space. And these ideas can be picked up and worked through using generative adversarial networks or other neural networks, because they have one ability that surpasses that which is human. They can really crunch through enormous amounts of data in a far faster pace than we as humans can, revealing underlying rules, connections, ideas, possibilities, but also aesthetics. Another example would be Oscar Martinez, with a similar idea, collecting large amounts of historic paintings and graphics and designs and connecting them to artworks that have a really uncanny quality to evoke responses in the observer. Now, basically speaking, that's one of the main acts of the artistic endeavor, is basically that you start as an observer a relationship to the piece of art, and that can be a provocation, that can be a romantic feeling. So it's really this sort of evoking of a response in the observer. And I think it's an incredible idea that through the use of actually known data, you can create something that is new. Now, discussing the problem of the new in itself already would be a long lecture, so I'm going to leave it at that. But let me show you, of course, one of the most famous examples of that area, which is the notoriously famous portrait of Edmond de Bellamy by the Paris-based artist group Obvious, which was sold at Christie's for $432,320 last year. And which is also, like Mario Klingemann's work, based on a database of thousands of historic portraits from the 15th to the 19th century. Now, there's a couple of questions that open up here that I think also become interesting in the architectural discourse. Like one being, who is the author of this work, right? Is it the artist group that came up with the idea of using a gun to create a painting? So in Marcel Duchamp's universe, that would be probably yes, these are the artists. But then what's with the programmer who programmed the neural network to create this piece of art? Is he part of that agency? Is he part of the authorship? Or what is it with the database, with the paintings in the database? How much do they contribute to the authorship of this painting? Or is the author really the neural network, the AI that created ultimately the piece of art? Now, these all are important questions in regards of how we progress with the same ideas and problems in architecture. Another aspect here, which is also valuable to discuss, is the problem of bias. So this database was primarily fed Western paintings from the Renaissance to the 19th century, depicting primarily white men and women. So it's definitely biased in a specific direction. Yeah? And I'm going to talk more about bias in a second. As a side note, the title of the painting, Edmond de Bellamy, might actually indicate towards the inventor of the generative adversarial network, whose name is Ian Goodfellow. He came up with the generative adversarial network 2015. Well, if you translate it into French, you could well say Bellamy, good friend. No? Now, how can architecture be part of that conversation? Of course, there is a history already to that relationship between architecture and artificial intelligence. Molly Wright-Steenson actually chronicled that very well in her book, Architectural Intelligence, where she actually demonstrated with 4 positions how ideas of automation, artificial intelligence, and computational design in general started to emerge within the architectural discipline, exemplified with the work of Christopher Alexander, Cedric Price, Richard Saul-Wurman, and Nicolas Negroponte. I can highly recommend this book if you want to have an idea of how this whole thing came up to be. But here we are again with this problem of bias, right? I mean, if you take this book, for example, it's very white, very male dominated. Yeah, so we need to critically interrogate this notion and understand how that actually can be tackled and changed in our contemporary age. Of course, I personally, I'm very optimistic about technology. I always like to pick it up as something that can inform my architecture design. However, there's of course also something like the dark side of AI, right? Which I don't want to omit here. So let me put it this way. Another aspect about how architecture is, or how the architectural discipline in a conversation about automation in our contemporary age has been involved in, you can think of that in the last decade, the conversation on automation and robots in architecture has been primarily dominated by a discussion about the capabilities of the tool to facilitate procedures or to create novel form of vocabularies. So conferences on robots and automation in architecture profoundly focus on the technological achievements and the many variations of material formations that can be accomplished using a robotic setup. From stacking exotic figurations of bricks to fiber winding panels inspired by biological phenomena to the meticulous and precise forming of metal sheets with robots, the research essentially focuses on the technological agencies. Yeah, this predominantly technical conversation just rarely touched on the larger issues at hand. Yeah? As to how automation might change aspects of cultural, social, and political discourse in the architectural discipline. To give you an example of how pressing that matter is, I'm going to talk to you about an algorithm that was developed in the United States to decide parole cases. Yeah, which brings me back to the problem of bias in the AI. So in ProPublica, that's a publication platform in the States. On May 26, 2016, Julia Angwin, Jeff Larson, Suya Matu, and Lauren Kirshner actually discussed the problem that there is bias in parole case softwares. Yeah, so these AIs were created to help parole lawyers to decide whether somebody gets parole or doesn't get parole. And these journalists figured out that this software was primarily given parole to white people, but not to people of color. Further research revealed that the database used to inform that neural network was racially biased. And the most incredible part about it was that it came about because one person who put together the database, was unconsciously racist. Yeah, so he didn't even know he's a racist. It just was in him, and it was somehow expressed with the database, which means that if you think about how databases are done today for the majority of neural networks, it's primarily white male dominated. So maybe a possibility to get out of it would be to diversify the work on artificial intelligence. So that's why I actually ask everyone to be part of it in order to make this whole thing more fair. In this extent, I would like to recommend also New Dark Age by James Bridle, which is a very interesting reading in regards to a variety of interesting problems around that. I'll keep this short here now about what is artificial intelligence. This is normally a longer lecture, which defines that in more detail. But let's keep it short with 3 specific aspects. Yeah, it has to have intentionality, it has to have intelligence, and it has to have adaptability. Yeah, intentionality and adaptability are a bit too straightforward to explain. Intelligence is a little bit more difficult and would take a little bit longer, so we're going to leave it at that for now. Just enough said that there is different conversations about what intelligence really entails, and there's different camps discussing it in different terms, which makes it a little bit complicated. But anyways, the bigger question might be, why use an AI in general at all? Yeah. Simply put, it's better to teach machines how to learn instead of how to do things. Like, what do I mean by that? Imagine an industrial robot in a production line of cars. And robots in car production have been around for 50 years plus now. So originally, all these robots had to be manually taught which are the welding points, for example, of this car. So you have to meticulously really control the robot, make it understand, here's the point where you have to weld, and then continue to the next point. And then he repeated that process over and over again, how long as the robot could keep up with the production speed. Now, imagine in that era where they were teaching robots manually where the welding points are, they changed from one model to the next model in the production line. They had to reteach the robot completely again, which was very time consuming and very costly also. Now, if you are able to feed a robot millions, or let's say tens of thousands of examples of what successful welding points are in a car, you can basically teach a robot not which is the point where you have to weld, but where would it be good to weld? Yeah? And then the robot automatically through machine vision can actually recognize where to weld the car instead of having to teach the points. What this means is that basically every single car that comes along the production line can be different. The robot will adaptability, here we are again, will adapt to the situation and start to weld the points where it's good to weld. I'm also going to keep this short. There's two specific trajectories of application, one being generalized AI, one being applied AI, and we're going to focus on the applied AIs, which basically means that they have one problem they need to solve, and they're really good in solving that one problem. A really well-known one is, for example, handwritten recognition, especially with numbers. This is one of the oldest applications out there for neural networks. Just think of, when you write a check that goes to the bank, I can assure you no one in a bank will ever look at your check. It's all going into a scanning system that then a neural network is fed through to understand what's a 5, for example. This is a simple example of a neural network with 4 layers, where we have a backpropagation system that allows us to understand what is, for example, in this extent, a 5. Now, this is all based on databases that have to be fed into the system. We heard about that already briefly before. You have to give him examples. What's a 5? And all these databases with thousands of images of 1s, 5s, 6s, 0s, and so on have to be labeled. And at the beginning, this is all done manually. So there has to be people sitting there labeling those images so that a neural network would understand the relationship between the content of the image and the semantic information. Meaning, this pixel array he's looking at, is that now a 5? So when he has this correlation, he can automatically repeat that process. Another really important aspect for how this will or is already influencing architecture design is something I call the post-human perception of the world. So as I mentioned before already, post-human doesn't mean after humans. It means basically just an era after human dominance of our discourse. And I think it's fascinating how machines actually perceive the world. This is a drone footage where you can recognize difference and distance by color and coloration. So it's a primitive 3D scan of this environment in order to understand distances. So robot vision based on LiDAR is a method to estimate the distance to objects, but that is not all. It needs to understand what is what, yeah? And for that, it uses a variety of different neural networks. So basically, it can understand its environment in a specific way, but interestingly, it's understanding the environment completely different to the way we as humans observe it. Now let's go into AI and creativity, the main discussion point today, I think, from this event. The first question is, can AIs be creative at all? Yeah, this is an image from the famous Bob and Dennis experiment by the Facebook Artificial Intelligence Research Unit done in 2017. The interesting thing that happened here, let me give you the premise of what this experiment was about. So the experiment was asking for an AI or a neural network that would be able to answer phone calls from people calling banks asking for specific, let's say, products of the bank or specific economical conversations. And the AI should be so good that the real person on the other end of the line would not recognize that he's talking to a robot. Now, in order to train that neural network, the scientists created an experiment in that they have two neural networks discussing with each other. And that was actually just there to train the neural network without having a person talking to it all the time, just to save time, basically. So they set up the experiment, they let it run overnight, they come back the next day, and next day these AIs had developed their own language. Yeah. So what you see here is the result of that conversation at the next day. So it says, I, everything else, ... And Alice answers, balls have 0 to me, to me, to me, to me. Okay. So the first time I heard about this experiment, I was completely flattened. I was like, okay, that's definitely proof for artificial intelligence being able to be creative. So I was completely fascinated about it. Further research, however, made me doubt a little bit that sort of very interesting premise, because if you think about it, like, first of all, it's in English. So it's not a completely new language, right? It's just relying still on English words to say something. Okay, that's the one thing. And the other thing is, I'm not sure if what is coming out of that conversation right here is really an improvement. If this is really optimizing the English language to discuss banking problems, because I don't understand what it says. And I have not read any article that proves that the scientists could decipher what they're talking about. Yeah. So, which could mean two things. Either they're really hiding something, the AIs, and they're so intelligent that they're already hiding it, or this is just a programming error, and what we see here is just garbage. So, not entirely sure about this. But there's another example, and more new one, which is the AlphaGo versus Lise et al. Game a couple of years ago, which I think is really interesting. And I can recommend to everyone to see the documentary if you want to see really a human person getting in despair because of an AI. The famous Move 37, you have to remember that name. The Move 37 was something that was really interesting because the AI made something that no human would do. So I remember that when the game was going on and the robot puts that stone there, everyone was like, "Oh, that must be a mistake. That doesn't make any sense," and so on. And it's really interesting that is absolutely not what happened. The robot was really creatively thinking forward of how the game is gonna move on, and he won the game. Yeah. And the interesting thing was that the moment that stone was set, and after a couple of minutes, people started to understand what that actually means. One of the commentators spontaneously, without thinking, said, "Oh, that's a creative move." So it was really a very natural thing to see that this machine was actually able to do something that is creative, eccentric, different, weird, but nonetheless successful. Yeah. So this could be really an interesting example of creativity within a machinic mind. I will go a little bit faster here now because I don't think we need to explain in detail how neural networks actually operate. That would be an own lecture and would take a little bit more time. So I'm going to hop over those. But I'm going to go into detail a little bit more about a project that we made based on all these sort of premises. Yeah, so you have this premise of these ideas about using neural networks and thinking about how creativity can be used in that and how we as a discipline can use our archive to come up with novel solutions. And one example I can give you here is the so-called robot garden, which was created using 2D to 3D style transfer technique. I have to say that we are pretty obsessed. When I say we, that's Sandra Manninger and myself as SPAN. And also, of course, the way how we teach these processes. We're quite fascinated about the possibility to do neural networks in 3D. We see that there is an inherent problem just using two-dimensional information when you're doing architectural design, and that could become a problem over time because you have to rely on almost dumbing down the techniques in order to get a three-dimensional project out of it. But if you really go completely 3D in neural networks, you might overcome that problem. I might add to this too that I'm completely convinced that this whole AI in architecture technique that a couple of people are working on now is probably the first genuinely 21st century design technique, considering that the vast majority of computational design methods that we have been using in the first 20 years of the 21st century were already developed in the 20th century. So if you think about parametricism, agent-based modeling, polygon modeling, NURBS modeling, all of these were already invented in the 20th century. They were just refined and polished in the 21st century. But this one here is really something new. And as we saw in the presentation before already, the rawness and coarseness of the results we're getting out of them that sometimes force people to optimize or rationalize them are already showing that there's something new here happening, which you don't really completely understand yet. Anyways, the robot garden was for this client here. The University of Michigan has a robotics lab where they are testing and developing further bipedal robots and quadpedal robots, and they were asking to design a test ground for the robots. And there was a variety of things that had to be done here. So it had to have a variety of different geological surfaces. It had to have steps. So we use like thousands of satellite images of different ground conditions to train a neural network to dream on top of the site that was given to us by the robotics department, which is a site just next to their newly being constructed building. So we dreamed a variety of different things here. Like first we dreamed fountains on it, and then we dreamed like rocks on it, and we dreamed sand on it. Like we dreamed a variety of things on this, more or less successfully, I have to say. This was our first project where we went that far. Some of the results were absolutely useless. Some of the results were a little bit more promising, and we had to go through really a lot of those different variations to come up with something that was successful. And ultimately, it came down to something like this. And this is like the final outcome of the project. Currently, we're also working on a set of boulders with the same technique that are going to go on site. And this is the final design of it. Construction plans. It was on show at the Vienna Biennale and the Buenos Aires Biennale last year. I really liked also some of the results we got, which were quote unquote useless. But I like this sort of provoking, useless, not entirely clear what it is results, because I think they're inspiring. They have a strangeness to them that I really appreciate. Here's again the boulders, and this is the current condition right now. So the concrete work is ready. The different layers of the different topographies and different ground conditions is ready. And right now we are in the fabrication process for the boulders and a couple of smaller details that, because of the pandemic, of course, this was all delayed. So it's going to come probably next spring. And another project we've been working on a lot is so-called imaginary plans, where we feed it a neural network. Again, like this idea of feeding a network thousands of Baroque plans, for example, to come up with something that has a Baroque quality to them, or to dream Baroque qualities onto modern plans. And what comes out of that is quite interesting, because it's something that is really weird and strange and has like thicknesses of Baroque examples, but at the same time it has for example, modern asymmetry. This is in more detail. We try not to optimize those. We try not to rationalize those plans. We take them as they are and try to deal now to understand what is poché, what is wall thickness, how does it contribute to the interiorities? Are they useful in some way? So yes, there's analysis going into this, but rather trying to keep the amount of rationalization as low as possible. Same with our projects called urban fictions, where we go up in scale with the same problem and try to create these urban scapes that are informed by a variety of input data. And finally, I would like to show you a project where we went a little bit more into detail with our design. So this is the design for a high school project in Shenzhen in China for a high school. It's called Peaches and Plums. It's quite a large school. This was a school for 3,000 students, about 100,000 square meters. So basically, just from the volume, it's like a small town. And we used neural networks to create the start of the project. We used a so-called attention gun. And attention guns are really interesting because you can actually feed them a sentence, and it will, out of that sentence, create an image. And they are basically designed to create images that are realistic. But if you twist the language, if you play with the language, you can come up with very strange, surreal, beautiful imagery. And in our case, we described the different points of the program, and we were very keen in using the topography of the site to our advantage, which you will see in a second how that played out. But again, to the attention gun, so we described aspects of the programmatic points of the school, like this colorful building contains the gym, which is great for all students, whatever, something like that. And it started to generate the images. And then out of the images, through using image mapping, we were actually able to create a three-dimensional version of that of the colorful result. We were really very happy with the extremely colorful results of this design. It's something very different compared to our all-over general oeuvre. As said, it's in Shenzhen, in the northwest part of Shenzhen, very close to the sea, which also means that the water table is very high here. And it was already a point in the description of the project rules that they wanted to have the parking underground, but we were supposed to figure out a method to go as little as possible into the water table. And we figured out that the site has quite a big difference in height from 0 to +8 meters. And using that height difference, we were able to maintain the parking garages underground without having to go into the water table at all. Again, also using the topography of the site to accommodate a variety of different parts of the program. So we created like a natural step in the site, and that step in the site was used to accommodate the running track and football field, and using the step as the part where we can put the ranks for the spectators. One thing we wanted to achieve, and the attention gun really helped us doing that, is creating something like a small town. So instead of creating one mega building that would contain the whole school, we broke it up into a variety of parts, rather creating like a long axis, and along that axis having different parts of the program, like the public. There's a convention, a small convention hall in there. There's a laboratory building in there, classroom clusters. The high buildings are dormitories. So it seems like it was really supposed to be a contained community of students and teachers. So teachers are also supposed to live on site. They had their own tower. And with that in mind, we really tried to create this small, like a small Italian village on a hill, let's say, so that it has this sort of feeling of community and connection. The interiors were kept super simple. And here we are again also with one of the problems using AIs in architecture. Right now, when you use, for example, 2D to 3D style transfer, like we showed before, you can only create either an exterior or an interior, but it's very hard to create something where interior and exterior are done at the same time. So we're really working on trying to get that to work. But for this project, we decided to keep the interior very, very simple and make the exteriors sort of the show, where you have that articulated, broken down volumes. the breaking down of the volumes was very important to achieve scale. So we wanted this school to have human scale. So it shouldn't be like this overwhelming large thing, but rather like this small scale, broken up, articulated bodies that allowed for a relationship between your own scale and the scale of the building. And we really kept the coloration that we got out of the attention gun for the buildings and for the ground and everything. So we tried to really be truthful to whatever we got out of the process, even if the buildings silhouettes looked broken up and strange and weird. We intentionally kept those, also with the colors, which gives it its own identity, and it's definitely different. Yeah. We also fared really well in this competition. I think we were under the first 4 of the competition. So we were already sure, like when we designed this, that there's only 2 things that can happen here. Either people are going to hate it or they're going to love it. So I think obviously we fell rather on the second side, but not enough to really win it. We also designed the structural engineering was done together with Bollinger Grohmann. They helped us out in designing the engineering in this project, and we worked together with a Chinese company in Shanghai, close to our office, who made all the cost estimates and calculations and everything. So this is really well developed and well thought through project that really helps to understand how you can use that environment of design in a large scale and with a rather detailed and realistic program. Let me go a little bit forward here after this here. Yeah, there's the animations at the end. So, and with this project, I would like to end my lecture. Again, thank you very much for the invitation. I hope this was informative to you guys, and looking forward for the conversation now.
Well, thanks a lot for that, both Enriqueta and Matias. And yeah, I would like to first of all, open the round. I mean, I have tons of questions, obviously, with such an amazing material. But let's see if there's anybody in the audience that would like to ask any question, because I think it has been we've had quite a lot of material and quite a lot of quite interesting work shown. So is there anybody that, let's see if anybody has raised their hands, or do they want to add something in the chat? Can't see anything. So I would, if nobody else has any question, I definitely have a ton of them. But generally speaking, it would be a question to both of. We have Erika, so I'll go to the question by Erika. Let's see if I can unmute, if I get this right. Erika, I think you can speak now.
Hi.
Okay.
Thank you very much for incredible lecture. I love the last project that Matias showed. It looks incredible. So I have a question about that project. So do I understand correctly, the AI part that you used was the GAN, the attention GAN, and then you transferred the images that it produced onto a 3D model? So like you used something like 3D models generation from photographs, then you made those images into 3D?
Just very briefly put, Grasshopper is something called an image mapper.
Okay.
Yeah, and what it does is it can recognize, patches of color and define them as a surface. Mm-hmm. And once we have surfaces, you can of course extrude them, right? So basically, that's what it did. So it's a very straightforward translation from an image to a 3D model. But again, as I said before, this is a little bit haphazard. Yeah. So I think that we really need to go to the point where we're using really three-dimensional models in a generative adversarial network, and that's what we're working on currently. We're going to present a paper about that at the upcoming Arcadia conference. So we did it. It works. Yeah. But we're going to show it for the first time at the Arcadia conference. It's coming up. It's free for students, by the way, if you guys still want to sign up.
Yeah, I'm signed up. I'll be there.
Okay.
Also, another question about the boulders and the sand. So there, did you use a 3D machine learning? What was it? What was it?
Yes.
I missed it.
So that one, I feel like I'm falling back to one of my lectures like 15 years ago, when the first questions I always got was, "How did you do that?" But okay, no problem. So then, it's a so-called 2D to 3D style transfer. Yeah. What it does is basically.
So you use the same thing basically in the sand one, no? No,
the sand one is 2D to 3D.
Okay.
Which basically takes the images and creates basically like a depth map. Yeah. Mm-hmm. And the last project is going through an image mapper, which is, it's two different processes.
Okay.
Yeah.
Yeah. Okay, I see. Thanks.
No problem. Thank you, Erica, for the question.
Thanks.
We have Mihaela.
Yes, hi. Hello.
Yeah.
Again, thank you for an amazing lecture. It's been really, really inspiring. I've got a question. A lot of influential art and design is generally realized from a place of emotion, for example, passion, despair, loss, love, etc., rather than pragmatism. So with AI, do you think the future of design would therefore be void of this? And what would be your commentary on AI and the value of emotion in design?
May I? Enriqueta,
Yeah.
is it okay if I start? Okay. Very good question. Well, I think there's a variety of ways to see that, because the data that goes in doesn't need to be emotionless, right? I mean, if I take a database of pieces of art, the sort of emotional response that they evoke will somehow be part of the information, no? So in fact, it's getting processed through another machine, I would say. Yeah. But it's always about the response that you as an observer have to the piece of art. Like, for example, the Mario Klingemann works that I showed. Yeah, these sort of really strange images of two heads and weird eyes and so on. Even if it's generated through a neural network, I still have an immediate visceral response to them. Right, I can recognize their quality as pieces of art, and I don't care so much how they're done. Right, I think if you think about a piece of art, I mean, in the rarest cases, I'm obsessed about how they're technically done. I don't care if Michelangelo used marble from Carrara or which kind of chisel he used. It's the result that actually counts, right? So it doesn't matter so much whether somebody's using a generative adversarial network or a piece of chalk to create a piece of art. And by the way, I wrote a whole AD about the problem of evoking through design. Okay. You can look it up if you like. Yeah.
Yeah. What's it called?
Evoking through design. Mood in contemporary architecture or something like that.
Okay, perfect. Thank you.
Yeah, I think in relation to whether AI could evoke emotions, I think we need to consider that AI doesn't act independently, but actually it is the interaction between the designer and the algorithm. So it's almost like training a child. So there is a linguistic relationship between the designer and the algorithm. The designer is still feeding in with the database, but it's also training and trying to frame what the algorithm learns. So in that sense, I think it is much likely to evoke emotions, also because of the structure of the AI. For sure, will. I think even like other forms of art, whether they are built or not, at the end of the day, is the designer who can evoke these emotions.
We have a question here from Patrick Schumacher. So, Patrick.
Hi guys. Hi Matthias. Great lecture. Good to see you guys. So I just want to elaborate a little bit on the question of creativity in this respect here, and what we might mean by it, and how much more creative these systems might be or not from what we have been doing up to now. So I mean, seems to me we want to look at creativity in the context of problem solving, not just say pure novelty is enough, right? So we want to have a certain performance, and ideally it's an innovation. So that would be the tall order. Could these systems be innovative, in that sense, creative, innovative? I think a lower bar is already, if you would for creative, would for me, the minimal version is you just create something different, something novel, something other, like an artist, sometimes who was just kind of a random mutation nearly. And that's relatively a low bar. And of course we have that possibility. But I think there is also already some value in generating a new solution, even if it's not better, but it's a good enough solution. Because it saves us some work. And we can let the machine do what a kind of mediocre assistant would do, and so on. So I think that's quite good. And whether we generating true innovations, that's the question. We would have to have a kind of success criteria defined, and we need to loop this into some kind of evaluation process. So it becomes a part of maybe an evolutionary algorithm or something like that, rather than we deciding. Because if this machine runs and it churns options, but it's hard to appraise whether they are better or worse. And it brings me back to this, you say it's a new 21st century technique, and I agree with that. Of course, it's something new, and it achieved unprecedented successes in other areas, like, in playing Go, or, maybe in having new levels of AI capacities in speech recognition and conversation and so on. The question is, what in architecture, can we define areas of problem areas and initial tasks where we see there's a chance for these systems to outdo what we have achieved so far? I mean, we have been talking about various generative systems for quite a while, and there are other ways of having constrained generation, so they're not kind of garbage. They're already searching something with an abstract machine constrained through a series of criteria, evolutionary algorithms of various types. So what is? I mean, that's a question. I have no answer to this yet. But if these systems could potentially be more powerful, and anyway, there's a new range of opportunities, particularly the utilization of databases. That's where the key is. And of course, we need initially to tag these and classify these databases. But we need to define more what these areas are, where we would be able to, first of all, initially generate things automatically. We do now need designers. But the question still remains: will that lead to an innovation potential? I mean, then you bring in, the let's say additional element of, for instance, style transfer and the meshing of two data sets. There's novelty, but probably it's more problematic whether this generates innovation. It tilts more to the side of novelty. But of course, then there's a chance that there's innovation, but then we need to have an evaluation system. So I'm just unpacking a little bit the discourse here. I'm very much interested in exploring these issues, and as you talk, you want to move from image databases to your 3D databases, and we need to not only we need to kind of classify them, qualify them, and there's a lot of intelligence to be invested, which is initially our collective intelligence, I guess, to generate and these databases and to formulate the problems where these techniques have an edge. And I'm not sure if you think they already have an edge in your work, other than, let's say, new aesthetic stimulation, which we don't know yet what they might mean.
There's a lot there, Patrick, to discuss. Yeah. I mean, that would be a whole conference on its own. So, I mean, basically speaking, there's two things that are important. Like, there's many things. It's just, let me start with what you asked about, for example, things like optimization and trying to understand the tool as something even more than just doing nice forms. Yeah, because I completely agree with you that that's necessary. Yeah, and this all comes down to two things: training and semantic information. Yeah, because on the ones you can, for example, and I've discussed this with my students too, like you can, for example, train a neural network to be able to scan plans that you have designed and figure out whether they comply with code. Yeah, and point out, okay, there is a problem or there's a problem. And that would be an easy problem to solve with neural networks. Yeah, just think about diagnostics in medicine. Yeah, they're like really far ahead of us in that area. They can achieve incredible precision already with AIs, predicting, looking through, for example, X-rays and being able to recognize there's a problem here. Yeah, they are close to being better than the best medical experts in that area. So for architecture, definitely the parts which are tedious and boring and take long time can be definitely cut down in time through using neural networks if you train the networks accordingly. Now, for the semantic information part, that's where really interesting things come up, because what we've been using, for example, in terms of plans and sections and things like that now, basically inform me about a general style, so to speak, of that plan or that section, right? My AIs can recognize a Baroque plan, they can recognize a modern plan, but they cannot recognize what's the toilet, what's the living room, or what's a door. Like very simple things, right? So you have to, and Enriqueta already said that before, it's like teaching a child. You really have to explain to this is a door. Yeah, and you have to explain this to an AI like 1,000 times. A child is more intelligent, by the way, because it understands that after like 3 times. Yeah, an AI cannot do that. You need to show him 1,000 or 3,000 doors until he understands that opening in the plan is a door and has a specific height and so on. So, and that's where what we're working on now, because it needs time to develop those databases. I spent the whole, yeah, so go ahead.
No.
No, I just wanted to, as a last word, I spent the whole summer training a 3D database, and it was tedious and time-consuming and horrible. And I was really thinking, what am I doing here? I have other better things to do than just going through a database and typing in what is. Yeah. Anyways, but it still needs time, Patrick.
Yeah, I think for me, what I found an edge in the design process is that, of course, these technologies have been used to replicate and to being smart enough to produce patterns that are similar to what the database is. But I think what is interesting, if you think about teaching a child, is playing with the database and mixing this database in order to start to ask certain design questions that you could not ask with other design tools. So, for example, in the second example, we were bending the database. The database was wrong. We mixed these two architectures to see what the child could come out. And of course, in that sense, you reframe in the creative process. The creative process always needs boundaries, needs limits in which the creativity takes place. So it is just at the beginning, but I think what is interesting is that you can compute with compute aspects related to history or to your memory. What is at the end of the day, you as a designer use your memory, your experience to propose your designs and to evoke emotions, but you are entering in a dialogue with a child in which the memory, you are designing its own memory, and this memory could be based in the experience of a world that is not the world that a human could experience, but a completely artificial world that you are designing as a designer in relation with the machine. For me, it evokes certain premises that Nicolas Negroponte was putting, that maybe design should be more a linguistic relationship between the computer rather than a more rational and data-driven relationship. So it comes back to certain premises that Nicolas Negroponte was saying in his early work, the architecture machine. So yeah, this is what I will reflect on so far.
I mean, let me add one more thing. I mean, I do accept novelty as a subset of creativity, which has value in itself. And even, you know, for later filtering, selecting, rationalization, exploration. So and I think there's a lot on that front where this is delivering. I mean, it reminds me and it reminds me of the early part of using computers, where what we generate is a lot of, you know, novelty, and we didn't know how we could become rational. So I think that it's a necessary element. I mean, I've always defended what I'm calling formal research as an important and necessary subset of an overall research project. If you want to generate true innovation later on, there will have to be also new forms. And if these are categorically new and kind of, let's say, in the category of the strange and otherness, then we are suddenly looking at a subset of a potential solution space, which we have not looked at before. And there might be solutions within there, which are superior to, or at least an additional to, with functional equivalence to the solutions we're finding in the spaces we've been looking at so far. So I think there's a lot of strength in that element when you do these kind of hybridization and style transfer and these kind of not just a stable database, but you start kind of manipulating, randomizing nearly, or mixing databases. It's more than, it's better than just randomizing, because it has two kind of rational morphologies. You start to meld them. So I accept that there's a kind of novelty which we should also, I didn't mean to dismiss it. It's just one step, which already is valuable. And probably if you style mix, you have parts of it will just be kind of pure novelty without much rationality, but within that there could be chance rationales, which could be very valuable to explore.
I mean, sorry.
No, just saying that there is a lot of risk and a lot of strange results that you get on the way. You just need to embrace them.
Yeah, exactly to that point. There's something about creativity in this process which is quite interesting, because and it depends on the amount of data you put in. Like, for example, if we go for a process where we want to perfectly analyze, rationalize, and optimize something, we need to put a lot of data in so that it understands the problem and starts to optimize. The problem with that is that probably that optimization would look pretty close to something we already know.
Sure.
Yeah. So, for me, the more interesting part is when you are not using that much data, that neural network is trying to make somehow sense of it. Yeah. And that's why it comes out with this weird and strange and beautiful results. And then there's another process going on, which is interesting, which is our interpretation of that result, the human interpretation of that result, because we see in that weird result a possibility. A perfectly trained AI would probably dismiss them because they don't work. Yeah. They don't work in the frame of that optimization. Yeah, and I mean, I'm a big proponent of saying not every architecture has to be optimized, because otherwise the architecture would be really boring. Yeah, great architecture is very rarely optimized to perfection. So I think that that feedback loop between an AI spitting out weird imagery and we as humans, as architects, being able to see, wait a second, I can do something with that. That's kind of interesting. I could, if I twitch it or that in that way. The funny thing is that neural networks and AIs are profoundly bad in that sort of recognizing opportunity in a mistake. Yeah, they always will go towards what works for them. Yeah, like, is it right or is it wrong? There is no in between. Humans have the weird possibility to see the in between.
I think in order to elaborate on that is the idea of awareness of what you're doing. And computers are never aware of what they are doing. They just follow discrete instructions, whether they are more similar to how the neurons discriminate and they send signals, or whether it's more optimization techniques. They follow an instruction, where humans, we are aware of what we are doing, and therefore we can introduce creativity. So at the end of the day, even if there is a creative process empowered by NI, the framework and the intentionality comes from a human. But what it can also get is really alien qualities that are alien to humans, and that it produce us a sense of a strangeness. And I think this is also really powerful in what you get. I always I like to see how the students react to their own designs. I was really surprised and enjoyed that the students tried to rationalize what they got, because they just couldn't cope with this strangeness and granularity and this weird resolution, which I found really interesting, the reaction itself of rationalization. Wanted to.
I guess this relates to the Go Movement 37 event, where the computer really caught everybody by surprise. But the problem is that the computer wasn't aware of the huge issue that it created in social networks. It wasn't aware of how critical it had been, really. I wonder what would happen if the computer had been aware and realized that not only he won the game, but he created something that all humans were completely dazzled by. And perhaps the computer would act differently if he knew that, hang on, I got the humans by surprise this time. And that perhaps closer to real creativity, I guess. The minute the computer understands that has really caught everybody by surprise, not only he did it well, but whether we have ways of training that's another issue, I guess.
I mean, that documentary has two extremely revealing moments, or that game, let me say. That game has two very revealing moments, like one being the Move 37, where definitely there is this emphasis towards creativity, and that the AI did something which was unexpected and new and different and eccentric. And then the other moment, which I think is very revealing, is when Lise Doll literally broke the AI, by a move that it made. So there was like the possibility of the human to respond to the AI, and because that's literally what happened. So he made a move, and then the system crashed because the AI couldn't cope with it. Yeah. So it seems that it's still a vulnerable system, right? Mm-hmm. So this and it's so dependent on, again, input and output information. But it's like the usual thing in every programming thing. We know that axiom from programming called garbage in, garbage out. So it's just the way how it works, yeah.
There has been recently an event that made me very happy, is that Roger Penrose got a Nobel Prize for physics, and despite he got the Nobel Prize for his studies on black holes, he has an extensive literature on human creativity and intelligence and its relationship with mathematics. And he really studies the physics of the brain and try to understand what makes human reasoning distinct from computation, and what are the limits of the mathematical formal formal expressions in order to develop intelligence. So I think this is a person that is normally not in the field of AI or architecture, but I would just recommend it. It's really a very inspiring thinking in the field of intelligence, creative thinking.
I mean, Matthias, we most really know this example, I think it's also from DeepMind. I mean, when you talk about restricting the database, you could also have another kind of restriction on the output. For instance, when you generate the image, you constrain the amount of pixels they could use or the amount of time they can produce. So and then you get a kind of, in that GAN play, you get also, let's say, creativity, where you have maybe a solution with less means of, you constrain the means. And then you get, you don't end up with the perfect versions. You get these kind of, let's say, minimal versions of an attempt to satisfy, for instance, draw a portrait, and in that case there were kind of line abstractions generated because there was a constraint on the output. These are kind of interesting. I wonder what what is interesting for me now in this kind of setup, and you studying all these precedents and the field. Where do you see, analogs and heuristics? I mean, I guess what you're doing, where that were transferable and empower us as architects to use these tools, coming in and learning from what, 5 years or so of experiences in other domains.
That's a really, really good question. I mean, first of all, on the one side there's two problems I'm trying to understand. And on the one side, the ontological problem, like how does it emerge? How does it become? Why is it there? And so on, like what does it do? And then on the other side, the epistemology, like what do I learn of that? What is my experience of understanding that problem now? And how can I apply that to an architectural problem? And right now, I think it's really about picking up like basic architectural problems and trying to work through them using this technique. Yeah, like really. Enriqueta had an example which was nice, which is the problem of figure ground. And specifically because neural networks are so good in recognizing foreground and background, you can do a lot with that. Yeah? And basically all these sort of weird landscapes of cityscapes that you see behind me and so in the lecture are a result of that problem. Like understanding how basically mass and void create urban structures. And I'm doing this with urban structures because they work really well with neural networks. Funny enough, it's really difficult to do that with a building. Yeah, that's the next problem I'm going to try to work on. Yeah, how to do it with a building. But in fact, the other thing is when you're asking about what is basically what would be the architectural progress using that, right? I mean, that's a big question. Like, is it useful for us as architects? I can tell you that I'm not 100% sure yet, yeah, because I figured out through working through all these processes that we already have some of these processes in architecture, and they're sometimes just faster, yeah. So, for example, 2D to 3D style transfer could be manually done using depth mapping in Maya. It's almost the same process. And I can do that probably much faster than an AI can do it because I have experience with that. I know how to work with that. Yeah. But maybe we need to dig deeper. And I think where it becomes interesting is where formations, and I am a formalist, you know that, Patrick, and I'm not ashamed to say that. Yeah. So I'm interested in form. I'm interested in shape. I'm interested in how things look like. Yeah. And because there is this whole moment of the results coming out of those neural networks are so much challenging me as a designer in terms of saying, what kind of aesthetic is this? Yes, it's alien, as Enriqueta already pointed out. There is estrangement to them. There is a certain defamiliarization going on, especially when you're using historic imagery, because you recognize parts of it, but it's not the same. Like the image behind me is based on a rendering I made a long time ago and the satellite image of Venice. And if you know that, you start to see, oh yes, those roof tiles and so on. Yeah, that they're kind of Venice-like, but the form is completely different. So there's this really strange collision between your own sensibility as a designer, specifically with this image behind me, your own sensibility as designer, and then the sensibility that is put on top by the neural network. And that fusion creates things that are provoking to me in terms of pushing forward and saying, yes, I can use that. I can do a design with that. And that's what we try to prove with the school, for example, at the end of my lecture. Like, how do I push that forward? It's not perfect, by far not perfect yet. It needs a lot of work, but it was the first proof of concept project for us, and we're going to push forward with that.
Okay, well, thanks a lot for the conversation. I think we will have chances to discuss about creativity, neural networks, CNNs, whatever, more times during this lecture series. But anyway, thanks a lot to both speakers and people contributing to the conversation to this very great event, which is basically the second of a series. We would like to ask everybody to come back next Monday, the 26th, for an absolute cracker. We have Kent Bai and Nina Schick, what we call merging critiques, basically discussing problems of deep fakes, ethics from artificial intelligence, all the problems generated. So, well, thanks a lot. Thanks a lot for that. And then, well, let's reconvene here next Monday. And thanks a lot for the conversation. We will try to see if we can make the recording available in the near future. And yeah, hope to see everybody here next Monday. Thanks a lot.
Eduardo, thanks a lot for the invitation. Just one quick thing. I know that a bunch of my students are online here. We're going to meet at 10 in our Zoom room. Okay? Good.
Bye-bye. Bye.
Bye, everyone. Thanks a lot for the invite. Bye, Enriqueta. Bye, Eduardo. Bye.